So we're going to look at piecewise functions. And a piecewise function is basically a larger function that's made up of smaller functions that are applicable only over certain ranges. So the way we're going to list this is we're going to do f of x is equal to, and it's going to be equal to a number of different smaller functions. So we're going to kind of go through these one by one. The first one is we're going to look at this one right here. And where it starts, it looks like it starts at x equals 2 and y equals -2, and then it continues horizontally indefinitely. So that means that we have a value of y equals -2 because it's a horizontal line. So I'm going to put -2. And this is true when x is greater than +2, because that's where it starts, and then it keeps going. We're not going to make it equal to or greater than 2 because we have an open circle, which means it's not going to be quite at 2, but just slightly above it. So we're not going to do that. Now, the other one that we're going to start with is over here. And this one, if you take a look, is -1 for x and up 2 for y. And it's also a horizontal line, so we're going to say y equals +2. And so we're going to do the same thing. It equals 2, and then it's when x is less than, because it's going toward the negative direction, -1, because that's where it started. And in this case, notice we have a closed circle, so we are going to make it equal to as well. So that's going to be kind of our defining piece of information, is if it's open or closed. And then the one in the middle is going to take us a little bit more effort. It's right here. And the easiest way, because it's not as easy as a horizontal line, is I'm going to redraw it over here just so that we can kind of see it a little bit easier. So we're going to make some lines. Okay, so it starts right here, right? And that point is 2, 0. And then the next point is right here, which is 1, 1. The next one is at 0, 2. And the final point is right here, which is going to be -1, 3. Now, there we go, we have this line. And so what we need to do is we need to find the equation of this line. And as you recall, equations of a line are y equals mx plus b. So we are going to find m. We're going to choose 2 of our points. I'm going to choose these first 2. And so we're going to do y2 minus y1 over x2 minus x1. M is going to be our x and y values. So we're going to do 0 minus 1 over 2 minus 1. And so what that gets us is -1 on top and +1 on the bottom. So our slope is -1. And then we're going to find our b. And the way we're going to do that is we're going to choose a point and just plug it in. So I'm just going to choose a different one for the sake of an example. And y is 2. Our m we just solved for was -1. The x for this point we just chose is 0. And then we have b. So 2 equals -1 times 0 is 0 plus b. So that means that 2 equals b, or for ease of reading, b equals 2. So our final equation for this section is going to be negative, and you can write -1x if you're comfortable with that, or you can just write -x plus 2, which is our b. All right, so we know what our equation is, so -x plus 2, and to figure out where this is going to be applicable, we need to look at the starting and ending point. So the starting point is right there, which is 2, 0, and it has a closed circle. And the ending point is -1, 3, and it has an open circle. So that tells us that the range we're going to do is -1 is less than, with an open circle, x, which is going to be within the range of 2. And notice at the 2, we have a closed circle, so we're going to put a line there. So that tells us that x is within the range of -1 and +2. And that is how you are going to solve this. So our final answer for this specific one is going to be f of x equals -2 when x is greater than 2, -x plus 2 when x is between -1 and +2 and equal to +2, and f of x is equal to 2 when x is less than or equal to -1. And that is how you are going to solve this problem.